Here's a slope field differential equation example. We may have even done this one at some point, but doubt you really remember it. The first thing is to create a slope field for this. So we won't do the whole thing. It's pretty easy. And you don't have to set up the whole chart, but you just pick an x and a y that's given and calculate what dy dx is based off this differential equation. So if you look at any point, say this point, I shouldn't mark it with an x because it will get confusing. This point is x equals 1, y equals 2. So plug 1 into here and 2 into the y. Anytime y is 2, you're going to get 0. So really, any value of x when y is 2 will give you a slope of 0. So right now I can do 3 points at once. Y equals 2, y equals 2, y equals 2. That's a slope of 0. You can also see, if you're going to go that way, that if you plug in 0 for x, it doesn't matter what y is. The dy dx is going to be 0. So anytime x is 0, you can now also write horizontal tangent lines. So then you only have a few more left to do. Let's just do -1 comma 3. So when x is -1 and y is 3, according to this, you will get 1 times 3 minus 2, which is 1. You get a slope of 1. So you need to draw a positive 45-degree slope. And then I missed. And then the rest of them are done just like that. That's pretty easy. Second question. While the slope field is drawn at only 12 points, it is defined everywhere in the xy plane. We need to describe all the points in the xy plane for which the slopes are negative. Well, the slopes are negative. Dy dx is negative. It doesn't depend on x because x is always positive, or the value you get, x to the fourth, is always positive, I should say. So the derivative is negative when this factor, y minus 2, is negative, less than 0. In other words, when y is less than 2. That answers the question. All the points in the xy plane for which the slopes are negative are all the points where y is less than 2. Now it says find the particular solution. So this is a differential equation, and we can separate the variables, and we use the initial condition. So this is, as always, solving differential equations are very simple. The problem is there's a lot of different little things you can do incorrectly. You just have to be careful. So I'm going to separate variables first. And I would show all these steps because you're going to get lots of partial credit for things you do right. Integrate. This is the natural log. This is 1/5 x to the fifth. Don't forget your plus c. That's very important. We can decide to solve for c right now, and I'm going to do that. We have f of 0 equals 0, so that means at 0 comma 0, ln of the absolute value of -2 equals c. That was easy. So we're going to take this general solution and make it a particular solution by plugging in that value we just got for c. And we would be done here except for the fact that in the directions they said it needs to be in the form y equals a function of x. So now we do have to simplify, or solve for y. So we're going to exponentiate both sides. we'll get the absolute value of y minus 2 equals e to the 1 over 5 x to the 5th time plus ln of 2, which is times e to the ln of 2. Don't necessarily have to do that, but it's simplifies it a little bit. So we have y minus 2 equals e to the ln of 2 is 2, e to the x to the 5th over 5. You may have noticed I dropped my absolute value signs. I shouldn't have. Now it's legit. I'm going to add 2. So here's my semi-final answer. I can't have two equations because it's not a function of x. It's the one that satisfies this initial condition. So when I plug in 0 for x, I need to get 0 equals y. So when I plug in 0 for x here, I'll get plus or minus 2. I do plus or minus 2 times 1 plus 2. So positive 2 plus 2 is 4. Negative 2 plus 2 is 0. Remember, I need this to be 0 because I need 0, 0 to be on the graph. Therefore, that forces me to pick the negative. That's x to the 5th over 2 plus 2. So this is my final answer. I'm going to write it over here because it's a little messy. I don't mean it to be. So I only found out that I was going to use this negative right here after I plugged in the initial condition. That's that.